All right, so this is the last part and the last video for lesson 3.8. I know it's been for unions and intersections of sets. Okay, so this time we will be solving inequalities that uses absolute values. All right, so in this case, what are the solutions of the absolute value of 2x minus 1 is less than 3? Okay, now remember, when we are solving inequalities, absolute value inequalities, you have to remember that if you have your absolute value expression, you keep the same inequality for the positive version, okay? And then if you have the negative version, okay, so if you are solving for the expression here, you have to flip the inequality for the negative version of the absolute value, okay? So let's have it here. So we have 2x minus 1. For the positive 3, it's going to be less than 3, okay? Keep the inequality. The other one, oops, sorry, my lights went out. Okay, the other one is, again, it's going to be 2x minus 1. Now, this time, for us to get a negative 3, we have to flip the inequality, okay? And so now we can already solve for this inequality, okay? So let's start with the blue. Oops, sorry. So we will have 2x minus 1 will be less than 3. Solving for x, we add 1 on both sides. You have a 2x is less than positive 4. We divide by 2. And so we have an expression that is x is less than positive 2. Okay? For the negative, for your negative version, so we will have 2x minus 1. This time it's going to be greater than negative 3. We follow the same step. Add 1 on both sides. You have 2x is greater than negative 3 and positive 1. That's a negative 2. Divide again by 2 for both sides. So we have an x is greater than negative 1. Okay? And so, if you are going to graph this, okay, one thing that you can do is you can graph it so that you can see if it is a union or intersection. Okay? Miss, how do I know if it is a union? How do I know if it's an intersection? Okay? If they meet, I'm gonna have it this way. If your graphs meet, this is an intersection. Okay? If your graphs are moving away from each other, that's when you have a union. All right? So we can look at the graph for this. So we have negative 1 is here, positive 2 is here, positive 2 is a less than, so it's going this way. Negative 1 is a greater than. And you know that they are going to meet. Okay? And again, when they meet, which one is it? It's the intersection. So when you write your final answer, since it's asking for the intersection, okay, I'm sorry, for the right solution as either union or intersection of two sets, let me just write it down here, okay? All right, so since we are using sets, so we will be using our set builder notation to show the intersection and union, okay? So we have the set, the set x wherein x is greater than negative 1. The other set is this one, the less than negative 2. So you have all the values of x wherein x is less than 2. And our symbol, as we have mentioned, since they connected to each other, it will be an intersection symbol. Okay? So that is how we write solutions of inequality, absolute values, with the use of union or intersections. Okay? Why don't you try this next example on your own? Figure out if it is a union or an intersection of two sets, and then of course write your solution in set builder notation. Okay, go ahead. All right, so if you follow our previous example, you will see that your absolute value expression, the positive, will stay as greater than. The negative version will be the opposite inequality, which is less than. So solving, you both add 6, you both divide by 4. Your equation, your inequality will have x is greater than 5. The other one is x is less than -2. How do you know if it is an intersection? If it is an intersection or a union, you can draw it. Okay, you can have the graph, and as you can see, they are doing the opposite way, and so that is a union. All right, and so writing them in set builder notation, we have the set x wherein x is less than 2, union with the set x wherein x is greater than 5. Okay. And so to summarize our lesson, given 2 or more sets, you can describe which elements belong to at least one set, okay? There are also elements that belong to all of the sets. And then, of course, we can always use symbols, your union symbol, your intersection symbol, to represent those relationships. All right.